Today we're going to see the study of the design of suspension systems in 3 dimensions. I believe that the analysis tools would allow us to analyze this as a mathematical model as well as a 3 dimensional model where we can verify actually how suspension works. So let's disappear from here. We have in here the different components of the suspension system. As you can see, these arms at the top, they look like letter A's. So in fact, they are called the upper A arm, yeah? And you have one on the bottom one that also looks like a letter A, which is lower A arm. In between those two, you have this spring, and of course, the suspension system will also have a damper to dissipate energy. And on the side, at the ending here, you have this is the steering wheel. So you have a kingpin in here that goes into the control arm, the upper and the lower. And then this whole thing is called a double A-arm suspension. Very common in American cars. Um, but now you have this other kind of suspension. This has a lower A arm, but you notice doesn't have an upper A arm. But instead of that, it has this assembly which is called a strut that is composed of a coil spring but also of a shock absorber. And this strut is connected to the body of the car at the top. So on both sides of the engine and the fenders, there is a very strong structure that actually uh, houses this assembly. So the vehicle has the suspension system, has the steering here, and the lower control arm here. So it has no upper control arm. This was more common on European cars, but it's popular right now also on Japanese cars and other vehicles. Here another type of suspension. Here we have a McPherson suspension. You can see that the vehicle has the lower arm in here connection, the side view of this part in here that has the steering arm and this whole assembly. What's over here? That's where the tire also would be, the axle and the tire would be mounted. And then of course this is a part that holds the base of the strut. And you have the damper and the spring here, and this would go to the side fenders usually. That's where this mounts. If you make an engineering model of this car and of the suspension system, you can do a two-dimensional model, as you can see here. You can do it with a body and linkages to be able to represent the kinematics of this car on a McPherson suspension. There are software programs like Working Model 2D which are very suitable for doing this kind of analysis. In this case, you can see that by using geometry, we can actually draw a perpendicular to this connection like this, and then you could draw a perpendicular to this other connection and determine where the roll center of the vehicle is. So there are certain advantages to the 2D model to be able to determine where this roll center is. And other properties of suspensions can be analyzed in 2D. This one here has if you look at this, um, they don't look extremely different except that the centers and the length of the linkages are a little different. So in this case, this produces an internal roll center depending on the length of the linkages, and B will produce external roll center. So this is why I'm saying the mechanism that we work in working model 2D can be really helpful for this. I think in a moment I would invite you to try this example using working model 2D and experience yourself what this is. And here you have different settings depending on the lengths of the linkages, as you can see. They will produce a suspension roll center, whether it is on the surface that the car rides, if it is above the surface, or if it is below the surface. So it all depends. As you can see, they don't look extremely different, but it depends on the lengths and the angles and where the axle is attached. Depending on that, you will see a change in the position of the roll center. I think just so that you can see the difference. This one in here is towards the bottom of this linkage, and as you increase that distance, you get the center on the surface. But you would a little bit, you don't have to go very much, you will produce a roll center that is below the surface. This is a more detailed kinematic model of this AA arm suspension mechanism. And now this is designed in more detail to study the effects of the position of the wheel on this. Because you see, if you consider this wheel to go up and down, um, the wheel itself is going to rotate somehow based on the kinematics of the linkage. So suspensions are designed for the wheel to travel a certain way, the way the designers intended. So, for example, if you take a turn at a high speed, you don't want the wheel to be coming in, caving in, but rather either to be in the vertical position or a little bit out, so that it will contribute to the stability of the car. Because if it comes all the way in, chances are you might roll over. So these are the basic parameters of the design of the linkages that go along with that belong to the suspension system. And as you can see from the kinematics point of view, the point where the wheel attaches to the axle can be considered what we call a coupler point. In other words, if this mechanism, this forward linkage, displaces one way or the other, the position of C becomes very important because that would be the position where the center of mass of the tire is, and does it become or move along a vertical line, or does it turn? And depends on what the answer is, would be the performance of the suspension. Chances are that if you have one where the tire does not cave in, you can go faster and the car would be stable. So in here, this is the different way that we have the connection to the of the strut. On the left hand, the strut is to the left of the vertical. It would be a negative caster, which is that position. This would have a positive caster. Now, caster is the rotation about the vertical axis, about the z-axis here. But in this case, camber is the inclination of the axis about the x-axis, see? So you have here camber or negative camber, positive camber or negative camber. What I was trying to say a moment ago is that you don't really want this negative camber because at high speeds, if the wheel gets inclined like that, chances are that you might roll over. So if it is with positive camber, when the curve demands the wheel to rotate clockwise from what we see in here, clockwise to a perpendicular axis, then chances are that you might be protected from rolling over because the wheel at the most would acquire a vertical position as opposed to the one on the right with a negative camber that would actually contribute to the vehicle rolling. So here is some examples of bodies with different roll centers that can be analyzed using working model 2D. So I would suggest that we determine the roll center, for example, of these problems using the geometry that and the construction of the cross section or the construction of the two-dimensional model of the suspension system. These are other problems that we might try, but in here basically wanted to have an idea of the way the suspension systems are built.